Computing and Artificial Intelligence, Part 1. Lecture 1. Introduction to the Computer from a User Perspective Learning Objectives. Understand the computer as a practical academic tool. Identify major domains of computer usage in university life. Recognize basic external computer components. Learn proper procedures for starting and shutting down a computer. Detailed explanation 1. What is a computer from a user perspective? From a user-oriented perspective, a computer is an electronic tool designed to support academic, administrative, and communication tasks efficiently and accurately. University students interact with computers primarily as end users, focusing on productivity rather than internal technical mechanisms. The computer enables students to prepare assignments, conduct academic research, manage digital resources, and communicate within the academic environment. In higher education, the computer functions as a central academic workspace, integrating writing, data handling, presentation, and online learning activities into a single digital platform, as shown in Figure 1. 2. Domains of computer usage. A. Education and study, writing reports, assignments, and projects, preparing academic presentations, accessing digital libraries and learning management systems. B. Professional and administrative tasks, organizing documents and records, managing schedules and simple datasets, using specialized software related to academic disciplines. C. Communication, academic email correspondence, online meetings and virtual lectures, collaborative work with peers and instructors, as shown in Figure 2. 3. External computer components. Monitor, the primary output device used to display text, images, and multimedia content. Keyboard, an input device used for entering text, numbers, and commands. Mouse, a pointing device that allows intuitive interaction with graphical user interfaces as shown in Figure 3. 4. Proper startup and shutdown procedures. Startup. 1. Ensure the device is connected to a power source. 2. Press the power button. 3. Wait until the operating system fully loads. Shutdown. 1. Save all open files. 2. Close active applications. 3. Select the shutdown option from the system menu. 4. Wait for the device to power off completely. Proper shutdown procedures protect system integrity and prevent data loss, as shown in Figure 4. Lecture 2. Fundamental Computer Components, a Functional Overview, Learning Objectives. Identify the major components of a computer system from a functional, user-level perspective. Explain what each component does in practical university use. Distinguish clearly between hardware and software at an end-user level. Detailed explanation 1. What are the main components of a computer system, functionally? A computer system can be understood as a set of components that cooperate to perform academic tasks, such as writing, searching, storing files, and presenting information. Functionally, these components fall into 4 groups: input, how you enter data and commands; processing, how the system executes instructions; output, how results are displayed or produced; storage, how files are saved for later use. This functional model is widely used in introductory information systems education because it helps users operate computers effectively without engineering-level detail, as shown in Figure 5. 2. Hardware versus software, user-oriented distinction. Hardware refers to the physical parts you can see and touch: monitor, keyboard, laptop body, printer. Software refers to the programs that run on the hardware: operating system, word browser, as shown in Figure 6. In practical terms, hardware is the device, while software is what makes the device useful. 3. Input devices: what they are and why students need them. Input devices allow the user to enter text, select options, and provide commands. Keyboard: typing reports, searching, entering numbers. Mouse/touchpad: selecting files, navigating menus. Scanner/camera when available: capturing documents or lab materials as shown in Figure 7. 4. Output devices: how results appear. Output devices present information to you: monitor, reading, viewing slides, attending online lectures. Printer, if needed, printing forms, reports, or submissions. Speakers/headphones, multimedia learning and online meetings, as shown in Figure 8. 5. Processing unit: what processing means for users. The processing unit executes instructions and coordinates tasks. For students, this affects responsiveness: how quickly applications open and run. Multitasking: ability to keep a browser, Word, and PDF reader open together as shown in Figure 9. 6. Storage: where your academic work lives. Storage is where files remain saved even after shutdown. Internal storage: HDD/SSD, your main device storage. External storage: USB drive, portable backup. Cloud storage, for example, Drive/OneDrive. Access files from multiple devices. Best practice in academic settings is to maintain at least one backup, external or cloud, to reduce data loss risk, as shown in Figure 10. Practical activity: identify input/output devices on a real computer. Locate storage on the device, this PC/Finder, and create a folder named Semester 1. Short discussion. Questions 1. Why is cloud storage useful for university students? 2. What problems might occur if a device has very limited RAM or storage, as shown in Figure 11? 2. The user interface: what students should recognize. Desktop, workspace where shortcuts and files appear. Taskbar/dock, quick access to running apps. Start menu/launcher, where you find and open programs. Windows and tabs, structure of working with multiple documents as shown in Figure 13. 3. Key daily operations: open an application, create and save a file, switch between applications, Alt+Tab/Command+Tab, close an application properly, as shown in Figure 14. 4. User accounts and permissions, basic. A user account helps protect files from other users on shared devices. Separate settings and documents, as shown in Figure 15. Practical activity: create a desktop folder named My Courses. Open Word or equivalent, type a short paragraph and save it into My Courses, as shown in Figure 16. Lecture 4. File and folder management for academic work learning objectives. Organize academic files using a consistent folder structure. Apply naming conventions for assignments and projects. Use copy/move/rename/search functions confidently. Detailed explanation 1. Why file management matters at university. University work quickly produces many digital items, reports, slides, PDFs. Without organization, students waste time and increase the risk of losing important work. Structured digital organization is associated with improved productivity and task completion, as shown in Figure 18. 3 are file naming rules, academic best practice. Use names that include course code /name, قل task type, auto, date or version. Example, Lilfo computer underscore assignment 1 underscore header underscore 2026 02 10.docx. Project underscore presentation underscore v2.pptx as shown in Figure 20. 4. Core operations. Create folders and subfolders. Move versus copy. Moving relocates. Copying duplicates. Rename to maintain order. Search to find files quickly, as shown in Figure 21. Practical activity. Build the folder structure above. Rename 3 sample files using the naming rule. Short discussion questions 1. What naming pattern helps you find files fastest? 2. When is copying better than moving? 2. Core academic structure of a short report. A basic university report often includes title plus student information, introduction, main content, sections, conclusion, references if required, as shown in Figure 23. Lecture 5. Word processing for academic documents, learning objectives. Produce a well-structured academic document. Apply essential formatting, headings, spacing, page numbers. Insert tables and references at a basic level. Detailed explanation 1. What is word processing in the university context? Word processing is the creation, editing, and formatting of academic documents such as assignments, lab reports, and project write-ups. Digital literacy frameworks in higher education treat word processing competence as foundational. Pearlson and Saunders, 2022, as shown in Figure 22. 3. Essential formatting skills. Headings, heading 1/2 for structure. Line spacing, for example 1.15 or 1.5. Page numbers, consistent font and size, as shown in Figure 24. 4. Useful features. Spell check and grammar suggestions. Table insertion for organized information. Export as PDF for submission, as shown in Figure 25. Short discussion. Questions 1. Why is PDF often preferred for submission? 2. What problems happen when formatting is inconsistent? Lecture 6. Spreadsheets for data organization learning objectives. Understand the spreadsheet as a tool for organizing data. Use basic formulas and functions, sum, average. Create a simple table suitable for academic use. Detailed explanation 1. What is a spreadsheet? User perspective. A spreadsheet is a grid-based tool used to store and manipulate data, especially numerical data. In university contexts, it supports grade tracking, lab measurements, and simple analyses. Stair and Reynolds 2021, as shown in Figure 27. 2. Core elements. Workbook/worksheet, rows and columns, cells and cell addresses. A1, B2, as shown in Figure 28. 3. Basic formulas. Equals sum open parenthesis, B2 colon B6 close parenthesis, equals average open parenthesis, C2 colon C6 close parenthesis 4. Good practices. Use clear column headers. Keep units consistent. Save versions open parenthesis V1 comma V2 close parenthesis if editing important data. Practical activity. Create a table. O student name, score 1, score 2, average. Calculate average for each student. Short discussion. Questions 1. What is the difference between data entry and formulas? 2. Why are headers and units important? Lecture 7. Academic presentations and visual communication learning objectives. Design a clear presentation suitable for university assessment. Apply basic slide design principles for readability. Deliver information using visual structure. Detailed explanation 1. What is the role of presentations at university? Presentations are used to communicate project outcomes, summarize research, and explain procedures. Multimedia learning research shows that well-designed visual materials can improve comprehension and retention, as shown in Figure 29. 2. Basic structure of an academic presentation. Title slide, agenda/outline, content slides 3 to 6, summary/conclusion, references if required, as shown in Figure 30. 3. Design rules, simple and effective. One main idea per slide. Use readable font sizes. Limit text. Use bullet points. Use figures/tables when helpful, as shown in Figure 31. Practical activity. Create a 5-slide presentation about computer skills for first-year students. 1. Title 2. Why computers matter. 3. File organization. 4. Word versus Excel. Uses. 5. Summary. Short discussion questions. 1. What makes a slide too crowded? 2. When should you use a table instead of text? Lecture 8. Internet use for academic purposes learning objectives. Use search engines strategically for academic work. Evaluate credibility of online sources. Download and store materials safely. Detailed explanation 1. What does academic internet use mean? It means using the internet to locate reliable information for study and research while applying critical thinking to verify credibility. Foundational networking and internet concepts support responsible use, as shown in Figure 32. Figure 32. Academic internet use 2. Searching effectively, university level. Use specific keywords. Use quotation marks for exact phrases. Use cite to search within a trusted domain, as shown in Figure 33. 3. Evaluating sources. Quick checklist. Author/organization credibility. Publication date. Evidence and references, bias and purpose, as shown in Figure 34. 4. Safe downloading. Prefer official/known sources. Avoid unknown executable files. Keep a clear folder for downloads as shown in Figure 35. Practical activity. Find one academic article or textbook chapter, PDF. Save it into Semester 1/course computer/lectures. Record the citation, author, title, year. Short discussion questions 1. What features indicate a source is unreliable? 2. Why should you record citations as you download materials? Lecture 9. Academic email and digital communication learning objectives. Write professional academic emails. Use clear subject lines and appropriate tone. Attach files correctly and safely. Detailed explanation 1. Why email matters in the academic environment. Email remains the formal channel for instructor communication, submissions, and official announcements. Professional etiquette improves clarity and academic credibility, as shown in Figure 36. 2. Anatomy of a professional academic email. Subject: specific and informative, e.g., course computer, assignment 1 submission. Greeting: Dear Doctor/Professor. Body: purpose plus key details, course section deadline. Attachment notes, name the attached file. Closing, name, ID, Department 3. Common mistakes to avoid: empty subject lines, informal language, missing attachments, sending unclear requests, as shown in Figure 37. Practical activity: compose an email to an instructor requesting clarification about an assignment. Attach a sample PDF named properly. Short discussion. Questions 1. Why is a specific subject line important? 2. What file naming rule helps instructors manage submissions? Lecture 10. Handling common user-level computer problems. Learning objectives. Identify common user-level issues and apply basic fixes. Know when to seek technical support. Apply safe practices to reduce recurring problems. Detailed explanation 1. What is basic troubleshooting for students? It is the ability to resolve minor operational issues, slow device, frozen app, printer error, using safe, standard steps. Basic troubleshooting improves user independence and reduces academic disruption, as shown in Figure 38. 2. Common problems and safe first steps. Application not responding. Wait, close the app, then reopen. Device slow, restart, close unused apps. No internet, check Wi-Fi, restart router if personal. Printer issues, check paper/ink, reselect printer as shown in Figure 39. 3. When to stop and ask for help. Repeated crashes, unusual system messages, suspected malware, important file corruption. 4. Prevention habits, save work frequently. Keep backups. Update software regularly, as shown in Figure 40. Practical activity. Simulate a frozen app scenario and practice closing and reopening safely. Create a backup folder and copy one key document into it. Short discussion questions 1. What is the safest first step when a device becomes unresponsive? 2. Why is frequent saving essential during long assignments?